Hello and welcome. This is the introduction for Spreader Bar Plus Calculator by Smarter Software. And what we want to do today is just walk through the features of the latest version. When you open the software, you'll be presented with this screen. It'll have a graphical results tab showing without anything filled in, and a results tab with everything zeroed out. The layout is set up into inputs on the left side. So this is where we'll put in the details of the spreader bar. We have a graphical representation here giving details as to what each component is, and then we have the graphical results and the tabulated results on the right. So we'll get started here. For the first part, under loads, we'll set the units that we'll do the calculation in. There are three primary units: the U.S. customary, British imperial, and the SI system of measurement. Also note that if you hover over the individual descriptions of the inputs, you'll get a little suggestion box or recommendation box or information box giving you a little bit more details. That's not on all of them, but on some of them it is. So it gives a little more details and maybe a recommendation. So for this spreader bar calculation, we'll just put in some numbers and run through an example and show the variations that the calculator can do. So when you open it up, it comes configured like this. You'll have some default numbers already in there, and we'll use those for right now. So we'll use a design category of B. It automatically populates the design factor for you. The input factor is going to be set to 1. The lifting load, lower shackle A and B, can be different, although the lifting load for A must be less than that of B. And so we'll just make that a little bit less. So we'll put 15 in there. So 15 tons. And we are going to have a spreader bar length of 15 feet. Let's make that 20. And we'll go up on our distance between lugs, and you'll notice as I made the spreader bar length larger, it updated and showed the difference between the lugs and the spreader bar lower shackles, giving you an indication that we are tighter down at the lugs than we are at the spreader bar. So let's change this. So if we want to have a little bit of fleeting out from the lugs, we can do that. So we'll make it 18 lugs. So just an example, and we'll get the updates down here. You'll also notice that it positioned the CG underneath the picture, giving length A and length B corresponding to the diagram in the center, length A and length B relative to the CG. It also gave the lug distance from the CG of 10.43 feet and 7.57 feet. So it kind of gives you an idea of where your hook is relative to the CG, or where it should be, I should say, to balance that out. All right. Lastly, we have the distance vertical height to CG. This would give you where your vessel CG is relative to the center line of your spreader bar. Keep that at 25 for now. So what we also have down here is a total that will calculate for the total lifting line as well. So let's move on to the end caps. So there are 3 styles of end caps that can be selected in this. The standard end cap with just 2 vertical holes there, with the top hole being in line with the end cap. Next is a link plank end cap design where this swivels freely relative to the top shackle hole, and that is in line with the spreader bar, the top hole. Lastly is an offset lug design end cap. As you select each one of these, you're general layout of the end cap will update and give you information as to what the deduct length is, the vertical offset from center line. Select this one here. And as you do, you'll notice that also we have grayed out inputs and some that were grayed out open up for those inputs. So as you make this selection, those will change. We'll stay with the standard for right now. Our end cap weight for this example, 200 pounds. And that's for one. I'll tell you what, it's 125 pounds for one. End cap deduct is, say, 15 inches. And the vertical offset from center line is the bottom hole relative to the top. It's 8 inches. Okay. So we'll move on to the spreader bar. Here's where we select the cross-sectional shape of the spreader bar. We have 3 styles to choose from: a pipe, round, HSS, and rectangular HSS. We're going to do a pipe right now, but we'll just go through a couple variations and show those. As we put in the top bar type, it'll automatically populate the bar sections, and you can look through and see we've got quite a few sections in there to choose from. As we do so, we'll notice that we'll get updates to the properties in the property list here pertaining to the steel pipe around HSS cross section. Notice that the direction of gravity, the X and Y axis here for our squared steel tubes, we have in a populated. As we change that, go to a rectangular, and we will select, say, 4x4 by 3/8 inch wall, and you'll see that it just reverses it in a for the circular cross section, and all the section properties are being filled in there. We do have 4 rectangular components, so say if we had a 4x2, we will get a rectangular cross section. This does allow a rotation of it relative to gravity, so if we want to rotate it, the x-axis is still here, the y-axis here, gravity acting in this fashion. So have some options to choose from an orientation if you're using a rectangular HSS cross section. So we'll go back to pipe. Let's go down to schedule 40. In here we'll have the steel material minimum yield strength of the bar. Hover over the description, we'll get a little bit of information concerning a couple of grades to choose from in that. We're going to use the pipe X52, and that has a 52 KSIU. And what we see here is from the ASME BTH-1 table 3-2-2-1, we have the width and thickness limit ratios for axial compression, flexural compact, and for flex non-compact. And so we'll, based upon the yield strength and modulus, it will populate this, and we check that relative to what our current cross section is. We show to be below required, so we should show to be good. In this calculation, I'm going to consider the spreader bar deflections. It will allow the consideration of the deflection under its own weight to be considered within the calculation. Okay. Next, we'll go over to shackles and slings. The first part of this is populated. We'll move over to the graphical results here and give some updates as we make our selections. Now for this example, we're going to use 40-ton wide bodies on top of our spreader bar and 40-ton wide bodies on the bottom. Our spreader bar length, go back to the beginning, was set to 20 feet. So we'll go and keep this at 20 feet. But we do have an offset CG based upon the loads that we had going into our lower shackles. So what we'll want to do to balance that, we already have a sling length based upon what we put in so far that that is required to put the hook over the CG. So we're going to use an 18.5, 18-foot 6-inch sling for sling B, and sling A, keep it 20. Next we'll select our top slings. We've got 3 to choose from. An I&I, 1 part mechanical. We have the strand grommet, and we also have a polyester inlet round. We'll use for this one mechanical, 1 part mechanical spliced I&I sling. Keep it in the vertical configuration. There are 2, vertical and basket. You'll notice that it'll update the picture on the side as you make your selection. And we get a flag note here that says the effective sling length will be half the sling length for the vertical basket. In other words, the true sling length is here, but the effective will be half of that since it's doubled over, which will be 10 feet. Next we'll select our bottom slings, and we'll put in the length of these 15 feet basically down to the lower shackle. And then we'll select those as well. We'll use, let's just use a spliced grommet. As we do so, it will make the visual update within the graphical representation. The size of this we'll use 1.5. On the bottoms we will use a bolt style. You'll notice that those update as well. And we will use an inch. All right. And then lastly, there will be a report. But once we've made it through all our selections, we should be good to run our calculation at this time. So let's go ahead and do it. It says that load is not centered under the hook. We'll shift to 12.5 until load CG is under the lifting hook. Okay, so we get some warnings here. And what happened is I didn't change this back to vertical, and so I cut my my slings way down, and so it aired out because it was not long enough to make the connection. So let's try this again. And we're back to vertical, and there we go. We'll notice that it did update the graphical results to have the top slings. It will update to have the shackles, upper and lower, and the bottom slings and the lower shackles as well. So we get a lot of information here on the graphical results. And we'll do, we've got basically our top slings. I'm not quite getting there for what we have selected. Actually, it got changed when I changed the vertical back. So there we go. Could probably go with a quarter, maybe a little lower. Not quite there on the heavy side of this. And there we go. So we run through the calculation to update it for the top slings, get the capacities where we need to be. And so we'll get a official report here of all the details from the geometry to the current percent capacity being used. You notice that the vertical deflection of the pipe due to its own weight is reported here. We do get a detailed description of the pipe spreader bar selected. The bottom slings, the lug location relative to the, and here we have the lifting load with the bottom shackle or lower shackles with the information here. Let's run this, but we'll use equal slings with the offset CG and see what happens here. we'll get a note that says the load is not centered under the hook. The CG will shift 17.2 inches until the load CG is under the lifting hook. So say OK. So we'll get an update and show that we have equal slings. This is showing equal slings, but we show that our CG is off to the right by 17.2 inches. We do get an estimation of rotation about the hook. In other words, that we expect to see 3.1 degrees of rotation of the spreader bar up in that direction. We'll go over to the tabulated results. And what we have here is 3 sections. One is the pipe and the tube, showing the capacities relative to the BTH equations. We also have the rigging, capacity and tension, and then we have the rigging weight and geometry. We'll notice that in the rigging component and loadings, our capacities after the tension, we have capacity in tons, capacity in percentage, percent capacity, and then we have over here our sling bending D over D and efficiencies relative to the shackles. So our D over D is relative to the shackles, so on our lower shackle we have a low D over D of 1.39. For our top sling and bottom sling, it selects the efficiency due to the D over D, and then for the bottom sling it selects the worst case from the lower and the bottom shackle to be presented here. Lastly, you'll see a termination efficiency. This has to do with the way the sling is terminated. I'll let you read up in the instructions and limitations document on what those are for the different slings that are programmed in. So, all right. Well, that is a short introduction. Let's go through a report right quick. The details of the report can be filled out here. I'll just show that we do have an update from the last version that allows you to put your company logo into the report. We'll just go through that right quick. So I'm going to browse for, say, this guy here. So select your company logo, and I'll forgo putting in all the descriptions there, and I'll just generate the report. We'll get a report that comes up like this, and we'll go to the print layout as it better describes, lays out all the information. And there we go. So we get a pretty good rundown of all the selected components as well as their percent capacities, and then we also get a graphical representation of the layout as well. All right. And that will do it for the short introduction to Spreader Bar Plus Calculator by SmartRigger Software. Thank you.